Welcome to 5 Minutes VHDL Podcast, the podcast where we talk about VHDL and hardware design. In this Q&A, I want to answer to Haitham. I hope I pronounced his name correctly. I received a question from him that contacted me in these days. He has the problem to connect a computer on FPGA using a USB connector in order to transfer data from FPGA to the PC. So I deal with this topic in my VHDL course, Start Learning VHDL Using FPGA. In this course, the last lab implements a communication between PC and FPGA using a UART link. After starting the course, Haitham asked me, does the USB transfer work as UART? So I decided to record this podcast to answer him and all the guys that could have the same problem. First of all, how do you think you have to implement a data transfer between FPGA and PC? Okay, you have to define some points before starting. The first is, who is the master? So, who is the master that handle the communication? The protocol you are using, and the link. In the last position is the link. USB, UART, LAN, wireless, Bluetooth, or whatever. In the lab relative to the course, the master is the PC. What this means? The software on the PC sends a request to the FPGA, and the FPGA answers to this request sending data. No data are sent to the PC without a PC request. This means PC is the master of the communication. This type of communication is implemented something like as polling. So, PC request and FPGA response. This approach is used to define the protocol. Now you can define that the two devices exchange data as a sequence of bytes. This means you need to specify what is the format of the data that transmits on the link. On the link, the data, for example, in the UART channel, the data communication is 1 bit per times, but the UART controller parallelize the bit on the link and provide the data on the interface. But this is the link. The number of bytes depends on the protocol you are using. So we assume to use byte as the smallest piece of information. This means that you need to specify what is the format of the data that transit on the link. For instance, we can define our protocol as start byte, type of command, read or write. And in case, for example, of command read, the message could be something like that. A start byte that defines that we are starting a message. The command ID, in this case, read. Command ID byte can be 1 in case of read, 2 in case of write, or whatever. The start address, the number of bytes you have to read, or the number of words defined as a multiple of bytes that you have to read from your device, in this case FPGA. For write command, the same start byte, command ID, that is a byte with a defined value that identify the write command, the start address, the number of bytes to write or words to write, and the data to write. In the last thing, you have to handle the physical link. And this is the answer to Haitham. In the lab in the course, you can find all the details of what I'm saying using the UART example. The lab implements a UART communication and Haitham needs a USB. Okay, when you design an hardware module, you need to take care to the interface. In the lab, the UART controller implements a UART protocol, physical protocol on the PC side with UART TX and RX. On the FPGA side, implements a FIFO-like interface. If you go on the Telegram channel, you will find a picture that should summarize this concept. So, if you need to implement a USB interface, the solution is very, very simple. Remove the UART controller and implement a FIFO controller using the same FIFO-like interface for what concerns the FPGA side and the USB controller for what concerns the PC side. For instance, if you are using FTDI chip, you have to implement the USB interface compatible with the FTDI chip, while on the FPGA side, you have to implement a FIFO-like interface. Remember also that FTDI implements also the USB to serial protocol, so you can communicate over a USB link using a UART protocol. If you use a Cypress chip, for example, you need to implement the interface to the Cypress device. But on the FPGA side, the interface and the VHDL code is always the same. Let me to make an example to understand the concept. I'm from Italy, so I'm Italian, I speak Italian. And I need to talk with, a French guy. So, if I can talk French or he can talk Italian, no problem, we can communicate without a problem. But I can talk in English, or if I can talk in English and he can talk in English, no problem also in this case. But if I can talk in English and he can't, here is a problem because we cannot understand each other. So, for now, if we have, for example, another guys that can talk in English with me and in French with the French guy, I can talk in English with this guy and he can translate to French for the French guy and vice versa. The French guy can talk in France with our translator that talk in English with me. In some sense, the FIFO-like interface implements this universal translator from USB, LAN, UART, or whatever other interface to the FIFO-like interface inside the FPGA. So, this is a general rule that you can adopt when you need to connect different modules. You can define a common interface for what concerns your design and then implements the interface to the external world using the interface that you need to implement. In this case, only the last interface will change. Your design, your VHDL design inside, in the back end, remains always the same. I hope I answered the question. On the episode description, you can find all the reference to the course, the picture, and the architecture. See you in the next episode, and ciao.